Okay, so today we're going to be finishing our last lesson in our radicals unit, and we're looking at 5.3, which is solving radical equations. So up until now, all of the radicals we've been working on have been expressions, so there's been no equal signs. And so now we're going to start looking at equations and how to solve them. So a radical is an equation, or a radical equation is an equation with a root in it. So it could be square root, cube root. The variables have to be underneath the radical. And there would be variables with radicals in the equation. So we would be solving for these variables. So there are two important things to make sure you check before you say you have a final answer. And so those two things are to identify any restrictions. So we've been doing a little bit of work with restrictions, but now we're going to work more deeply in them and also be checking them quite often. So denominators we know cannot be equal to 0. And then we know that if the index is an even number, the radicands have to be positive. So we've looked a little into that already. We can't take the square root of a negative. So the second thing we're also going to need to check is to see if we need to reject any of our solutions. So if we reject them, that means the roots are extraneous and they don't work in the equation. So we'll always check our solutions before we say they're our final answer. So now looking here at the first example, we're going to go through the steps, and these are the steps you'd follow each time to solve an equation. So the first step should always be to identify any restrictions. And so how you would find the restrictions is you look for the radicals. Underneath the square root, we know that expression has to be greater than or equal to 0, right? It has to be positive. We can't take the square root of a negative. So whatever is under that root, we set it greater than or equal to 0, and then we solve for the variable. So here we just need to add 5 to both sides, and we get the restriction that x has to be greater than or equal to 5. So as long as the solution that we get is greater than or equal to 5, it passes that first check. Okay, so how do we solve this radical? So once we're ready to go, our first step is to try and isolate the radical by itself on one side, if there's one radical. So we're going to start with one radical, and then we'll move to two radical questions. Okay, so looking here to see how can we isolate the radical, this root x minus 5 is being subtracted by 3. So we would add 3 to both sides. And at that point, we would get the radical isolated on one side by itself. So we get x minus 5 equals, and then that would be positive 2. So once the radical is isolated, we're ready to get rid of it by squaring. So the opposite of a square root is to square. So we would square both sides of the equation, because whatever we do to one side, we have to do to the other. And that would give us on one side, right, the square root of x minus 5 squared would be x minus 5, so the radical disappears. And then on the other side, we get a positive 4. So at this point, depending what we have left over, there may be a lot of work to do. And some of the harder questions, there would be step 4 and step 5. But this one, we can skip straight to step 6. So that's solving for the variable. So here we have x minus 5 equals 4. So we would add 5 to both sides, and we end up with x equals 9. Okay, so at this point, we would want to check that solution against our restriction. So we said originally that x had to be greater than or equal to 5. And since x equals 9 is greater than or equal to 5, it follows that restriction. So far we don't need to reject it. And then the very last step to saying it truly is the solution is to check our answer. So what that means is we write the original radical out, the radical equation out. Okay, we're going to check that does x really equal 9. So everywhere there's an x in the equation, we replace it by 9. So here I'm getting 9 minus 5 minus 3 equals negative 1. So back to the original. And then we simplify on each side just using BEDMAS. So you can do one side at a time. So on this side on the left, I'm going to simplify 9 minus 5 is a 4. So I have the square root of 4 minus 3, so that would be 2 minus 3. So that's going to give me a negative 1. And then on the right side, there's no simplifying to be done. That's just negative 1, so I carry it down. And if in the end I get that the left-hand side equals the right-hand side, that means my solution works. So not only did it pass the restriction, but it passed the check. So then x minus 9 is truly the solution. So lots of work and lots of things to remember as you solve the equations. So let's try another one. So looking at example 2 here. So once again, if you remember what the first step is, we're isolating the radical. So this radical is being added to 6 and multiplied by 2. And so with that, we are going to isolate it by first subtracting 6 on both sides. So I get 2 times the square root of x plus 1 equals 6. And then depending if the number in front of the root, like the coefficient in front of the root, if it can divide nicely, we would want to divide it out. So here 6 can be divided by 2, so I would simplify it that way. If it doesn't divide nicely, we don't really want to work with fractions, so we would just leave it where it is. So at this point, the radical is isolated, so I'd be ready to apply the square. And so now I'm ready to take the square root, or pardon me, the square of the square root. So that would just give me x plus 1, whatever's underneath. And on this side, I get 9. So here I don't have any cleaning up to do or anything like that besides subtracting 1 on both sides to get a final answer of x equals 8. Now there's 2 things I need to do to make sure that is the true answer. And one is to take the radicand. So that has to be positive because it's under a square root. So I would be setting that to greater than equal to 0. Solving for x. So I get x has to be greater than or equal to negative 1. So positive 8 is definitely greater than or equal to negative 1, so it passes that test. The next test is to check the solution. So I'm checking, does x actually equal 8? Does it work in the equation? So I go back to the original equation and replace the x by an 8. And then I'm just simplifying. The right-hand side has no simplifying to be done. So I can just simplify on the left-hand side. So following BEDMAS, I would first simplify under the root. So I have 2 times the root of 9 plus 6. The root of 9 we know is 3. So I'd have 2 times 3 plus 6. 2 times 3 is 6. So 6 plus 6. And then finally, and you can skip a few steps if you want to do a couple steps at once. Can't skip all the steps and just say like 12 equals 12. I need to see some of the work along the way. But here we would get a 12 on the left side. We were just carrying down a 12 on the right side. So we get a match. So this truly would be the solution of x equals 8. So sometimes it doesn't work out, and we're going to see some today that don't. But it's always important to do both the restriction and the check to get a full solution. So let's try this one now. So thinking about what needs to be done first. So that would be to isolate the radical. So if you look at the radical, this minus 2 is on the outside. So our first step would be add 2 to both sides to isolate the radical. So I've got the square root of 3y minus 1 equals positive 7. Okay, so now we're ready to, so since the radical is isolated, we're ready to square both sides. So if I square the square root of 3y minus 1, I get 3y minus 1. And then on the other side, I would get 49. So here, isolating y to solve for y, I'm adding 1 to both sides. So I get 3y equals 50. And last step, divide by 3. And we would just leave it as a fraction of 50 over 3. Okay, so to check if that truly is the answer, we're going to do two things. One being check the restriction. So I'm looking underneath the radical. Here I've got 3y minus 1. And so that needs to come out as a positive. So we've got 3y minus 1 has to be greater than or equal to 0. So under that radical, we have to have a positive come out. So if we add 1 to both sides, we get 3y is greater than or equal to 1. Dividing by 3, we get that y has to be greater than or equal to 1/3. So 50 over 3 is definitely greater than or equal to 1/3. Okay, so now we need to test it in a check. And so this may look a little bit daunting at first just because it's a fraction that we're checking, but when we substitute it in, it ends up being not so bad to simplify. So we're checking, does y actually equal 50 over 3? So wherever the variable is, we are replacing it by 50 over 3. And then we have the minus 1, that's still underneath the root, but the minus 2 is outside, and then the 5 on the right-hand side. So simplifying this first, looking at the 3 times 50 divided by 3, the 3's would cancel out, right? 3 divided by 3. So I'd get the square root of 50 minus 1, so I can go straight to 49 there. Then I have a minus 2, and then an equals 5. So looking at the square root of 49 minus 2, the square root of 49 is 7, so 7 minus 2. And then we go all the way down, so we're simplifying the left-hand side to check does it match the 5 on the right-hand side, and it does. So y equals 50 over 3 passes both of those tests, so that would be our solution. So now we can get a little bit more complicated for sure by looking at the next question where there are 2 radicals present in the question. So if we look at this next one, I have a radical on both sides of the equation. And so that's ideal for the squaring process. We want to have the radicals both on either side, and we'll see a few different examples where we have to do a little bit of work first before we square, but it's ideal to have them split up, and so we don't have to work with any kind of foiling of radicals. So one of the main differences with the 2 radicals is we have basically 2 sections that we need to do restrictions for. So that would be the x minus 8 underneath the 1 radical has to be greater than or equal to 0. So if I add 8 to both sides, I get that x has to be greater than or equal to 8. And then under the other radical, 3x plus 1 also has to come out positive. So if I subtract 1 on both sides and then divide by 3, I get that x has to be greater than or equal to negative 1/3. So when we get ourselves in a situation with 2 restrictions, what we need to find is which restriction kind of trumps the other restriction. So what I mean by that is you can put them both on a number line. So I'm just going to draw it up here. So remembering how you would put a inequality on a number line. So here if I have positive 8, I'm looking at anything greater than positive 8 for the first one. And then for the other restriction, it was anything greater than negative 1/3. So if I look at these 2 restrictions, you're kind of looking at which area does the graph meet both the criteria, and so where does it basically overlap. So once we get to the 8, that's where both of them overlap. So if I were to pick a number between negative 1/3 and 8, I only meet one of the restrictions. So I have to be able to meet both of the restrictions. So that would mean that x is greater than or equal to 8 is going to be the restriction that we go with. So they both have to be met with the criteria there. We'll do that a couple times in case that's a bit confusing. Okay, so once the radicals are isolated, we're ready to square. Now the 2 and the 3 in the front, if there was something common we could divide out, this would be a good time to do it. but 2 and 3 don't share any common factors, so we're just going to leave them as is. So now we're ready to square. So we'll do it to both sides. The 2 in the front gets squared, and the x minus 8. So don't forget to square the 2. So 2 squared would be a 4, and then root of x minus 8 would be x minus 4. On the other side, 3 squared would be a 9, and then the root of 3x plus 1 would be 3x plus 1. So at this point in time, we would do some distributing to get 4x minus 32 equals 27x plus 9. So you may think back to your grade 9 algebra solving, so where we have variables on both sides and we've got to work through and solve for x. So usually we would look at both of the x's. We would take the lower amount and do the opposite to get the x's on the same side. So if I subtract 4x from both sides, I end up with just x on the right side now. And then I'd also need to move the 9 over to the other side to keep it away from the x. So after this step, I would get negative 41 equals, and that would be 23x. And then in this last step, I'd be dividing both sides by 23. So of course, that's not a very nice number. There's no common factors between 41 and 23, so that would be lowest terms. And we wouldn't be working with decimals. This is a non-calculator unit. Okay, looking at our restriction, we said, looking back at the top, that x had to be greater than or equal to 8. As soon as I look at this, x is a negative. That's definitely not greater than 8. So we would have to reject that and say no solution. So we don't even need to check that because we automatically know it doesn't fit with the restriction. So it wouldn't be able to make a positive underneath the radical there. Okay, so let's look at the next example. So for example 5, this one definitely looks a lot more complicated. One thing that I notice about it is the radicands actually match. And so with that, we can actually combine them to make it easier and not have the two radicals. So what we can do is bring them to one side. So I could add 5x times the square root of 2x on both sides. So I can only do this because of the match, right? And so that would leave me with just a 4 on the left side and then an 8 minus, so it would actually be a plus because 5 plus 3, or 5 plus negative 3 times the square root of 2x. So I'd also want to, since the 8 can be combined with the 4, subtract the 8 and just get things as condensed as we can before we square both sides. Okay, so at this point in time, we haven't done this yet, but you could maybe notice that the coefficient in front of the 2x, the 2 can be divided on both sides evenly. So we just wanted to reduce things as much as possible. And so there we end up with the 2x. So look at what we have for a minute. At this point in time, not going to give anything away, but thinking about what does this look like? Do you have any red flags after seeing this step here? Okay, so if you don't, we're going to go ahead and solve. So square both sides. We get 4 equals 2x, and then dividing both sides by 2, we get that x equals 2. So checking out our restriction under both radicals, it's the same radicand, so we only have to do it once. So it would be 2x has to be greater than or equal to 0. So divide both sides by 2. X has to be greater than or equal to 0. So our solution passes that test because 2 is greater than or equal to 0. When I go to do my check, does it work? Okay, so replacing the x. So I have 4 minus 5 times the square root of 2 times 2. And then on the other side, I have 8 minus 3 times the square root of 2 times 2. So this is the first time we're going to have to simplify on both sides. And so you can do one side. Lots of people like just concentrating on one side at a time. And so that's what we'll do. So on the left side here, The first thing I'm going to simplify is underneath the root sign. So 2 times 2 is a 4. And so then I would have 4 minus 5. The square root of 4 would be 2. So careful with BEDMAS here. I can't subtract the 4 from the 5 or the 5 from the 4. I have to multiply first. So 4 subtract 10 would be a negative 6 on this left side. Okay, then moving along to the right side, I have the same kind of thing with the square root of 4. So I have 8 minus 3, and the square root of 4 is 2. So I get 8 minus 6 would give me a positive 2. So this obviously is a huge red flag. The check doesn't work. One thing I would always suggest is if you get a check that doesn't work, go back through your work just to make sure you didn't make like a little BEDMAS mistake. If you can't find any mistake and it truly doesn't work, so you'd say negative 6 is not equal to 2. So we would need to reject the answer. So the answer, that solution just doesn't work, and this happens all the time. And so we would reject. I can still see the x minus 2, but we're rejecting it and saying because that was the only option and that one doesn't work, that there's no solution. So one thing that I want to point out that I mentioned to kind of have a look at before was when we got to this stage here. And so that was 2, or it was like at the stage after, I guess, before I squared it. When I had that, the square root of 2x was equal to negative 2. So that should have been a little bit of a red flag. And at that point, if you notice the red flag, you could stop and already say no solution. And that's because I can't take the square root of anything and get a negative number. So that's the issue with this question and solving, that there really is no value of x that would work in this equation because I can't do that step. It's not possible. So this one had no solution. It was kind of doomed from the beginning. There was no solution to begin with. So that was proved through our check, and that's where it got caught in the check process. Okay, let's try the next one below. So this one we have 2 radicals. We've got that kind of 3 minus in the front there. There's nothing really we can do about that. It can't be combined anywhere and it can't really go away. So we would just be starting at this point. So you're always trying to make things be easier after you square to not make like a bigger mess. But at this point, there's nothing that can be done with that 3 in the front. So our first step would be just going ahead and squaring both sides. Notice how on the left side, squaring the square root of x plus 2, that's just going to give me an x plus 2. But on the right side, be very careful with this. I have a binomial squared. And so if you remember, that simply doesn't equal 3 squared minus the square root of x plus 7 squared. We'd actually have to multiply it all out. It means there's 2 of these identical brackets. So with that, so a binomial times a binomial, our strategy would be FOIL. So first would be 3 times 3. So that's going to give me a 9. Then I'm doing inside outside. So inside outside would actually match. Negative 3 times root x plus 7 on the inside. And then negative 3 times root x plus 7 on the outside. And then my last, I'm taking the square root of x plus 7 times the square root of x plus 7. It's a negative times a negative. And since those match exactly, the square roots would cancel with the square, and I just get x plus 7. So here we'd have some cleaning up to do for sure. So I'm just going to start cleaning up on the right side first. So I can combine the numbers together. So that's going to give me a 16. And I could also combine these roots. The radicands match perfectly. So a minus 3 and a minus 3 would make a minus 6. Root x plus 7. And then don't forget about that x at the end there. Okay, so before if I look at this, even though the squaring did help, it got rid of one of the radicals, I still have a radical left. So there may be, when you get a complicated question, the chance that you have to do the squaring twice. So before I do the squaring again, I would want to isolate the radical as best I can. And so with that, I would move the 16 to the other side. I would want to move the x to the other side. So I'm trying to get the radical as best as I can by itself. So what would happen actually is the x's cancel each other out, so they're gone there. 2 plus negative 16 would be negative 14. And then on the right side, I'm just left with negative 6 times x, square root of x plus 7. So this would be a good time to do some reducing, right? If we can find anything to simplify, we will, to make things easier. So both left and right hand side have a negative, so we could divide by negative, multiply by negative. Either way, we cancel the negative out. And then if I look at 14 and 6, they could also be divided by 2. So that just makes them a little bit smaller of numbers for us to work with. So now at this point, we're left with 7 and then a 3 root x plus 7. Now, in another one of the questions, we could have divided by the 3 to really get the radical isolated, but at this point, that would make a fraction, and we're not looking to make things more complicated for ourselves, so at this point, we would leave that for now. So you can do it, but only if it evenly simplifies. Okay, so here we're ready to square both sides. So I'm squaring the left side, squaring the right side. So I get 49. When you square the right side, don't forget to square the 3. And then the x plus 7 loses that root. So distribute. 49 equals 9x plus 63. And then just two-step equation to solve for x. So subtracting 63 on both sides first. So I'm left with negative 14 equals 9x. And then finally dividing both sides by 9 here. Okay, so this is giving me x equals negative 14 over 9. So next thing I would want to do, and you can, if you remember to do the restriction right at the beginning, you can do the restriction right at the beginning, but at this point, if I've forgotten to do it, I'll need to do it now. So looking under the two radicals, so for the first radical, my x plus 2 has to be greater than or equal to 0. So if I subtract that from both sides, I get x has to be greater than or equal to negative 2. And then under that second root, I need x plus 7 to be greater than or equal to 0, right? It has to be positive underneath. So that gives me x has to be greater than negative 7. So this is another example where we end up with two restrictions. So we want to combine the restriction to find the overall restriction. So here if I have negative 7 and negative 2, looking at the fact that x has to be greater than negative 7, so we're going this way. X has to also be greater than negative 2, so going that way. The overlap region is here. Okay, if I choose a number between negative 7 and negative 2, I don't meet that other criteria, so I have to choose one that's greater than or equal to negative 2. So looking at my number there, negative 14 over 9, so would be greater than negative 2, so it passes that test. And then the last test is the check. So I know we don't usually love to sub in fractions, but we're going to be doing that here. Usually they simplify nicely, so it's not as painful as it initially will seem. So we're replacing all the x's by negative 14 over 9. So on the left side, I have negative 14 over 9 plus 2 tucked under the radical. On the right side, I have 3 minus the square root of negative 14 over 9 plus 7. So thinking about how do I add fractions, well, you need common denominators for these. So the common denominator on the left side would be 9. So I want to rewrite the 2 over 9. So right now it's over 1. So if I multiply top and bottom by 9, I'm getting 18 over 9. So therefore I can go ahead and add here. So on the top, negative 14 plus 18 is positive 4. And then on the bottom, when you're adding fractions, you just keep the bottom the same. And then the square root of 4 and the square root of 9 are both perfect squares. So that ends up giving me a 2/3 for the left side. Okay, so now I'll go ahead and simplify on the right side. Same kind of idea. The 7 is over 1, so I need common denominators. So multiplying both the top and bottom by 9. I get 63 over 9. So on this side, I've got a little more work to do. Underneath the radical, 63 plus negative 14 would give me positive 49, and then the bottom stays the same. So if I take the square root of, so I've got this 3 minus, the square root of 49 is 7, the square root of 9 is 3. So here I need a little bit more room to keep going. Left side was 2/3. Right side, once again, I need to do common denominators again. This 3 is over 1, so I need to get it over 3. So I'm going to multiply top and bottom by 3. Now I'm ready to subtract. 9 minus 7 is a 2, and 3 on the bottom. So I get a match, and so that means that x minus 14 over 9 is truly the answer. It passes both the restriction and it passes the check. Okay, let's try the next one. I'm just going to erase some of this so I can get it out of the way. Whoops. Okay, and so zooming in on the next one, take a second to think about how do you get that radical isolated. So here I'm back to one radical now for this question. I've got it the n minus on that side, so I want to kind of clean that up a bit. So I would need to bring it to the other side to work with that. So what I could do is, since the radical has a negative, okay, and this 7 has a negative, it might be a good idea to flip those two to other sides, or you could move the n over and then just divide everything by a negative to get rid of all those negatives. But either way, I'm going to move the 7 over here, and then I'm going to move the 5 minus n to the right side. So I end up with n plus 7 equals the square root of 5 minus n. So I added 7 to both sides. I added the square root of 5 minus n to both sides. So now everything's positive. If you ended up flipping it to the other direction, then at this point you could just divide everything by negative to make it all positive. Okay, so ready to square since my radical is isolated. So notice when I square the left side, I actually end up with a binomial squared. So it's not n squared plus 49, it's n plus 7 times n plus 7. So there's 2 of those. And then the right side, there's just a 5 minus n. So on the left side, I would need to FOIL this out. So first gives me n times n. Inside, outside, both give me 7n. And then last would be 7 times 7, which is 49. And then on the right side, I still have the 5 minus n. So I'm going to collect any like terms and move everything to one side because I need to solve for n. This is going to probably require us to do a little bit of factoring because of that n squared at this point. So I'm going to move the n over to the other side. I'm going to move the 5 over to the other side. So I have a plus n and a minus 5 now on that side. Okay, so collecting like terms, I have n squared. 7n plus 7n plus 1n would be 15n. And then 49 minus 5 would be positive 44. So this must look familiar to you from our last unit where we were solving quadratic equations. So here we would factor to solve. So we're hoping that this ends up factorable. So we're looking for two numbers that multiply to give us 44, but add to give us 15. So if you're thinking positive 11 and positive 4, you're right. So the solution here, we'd actually get two solutions, n equals negative 11 and n equals negative 4. So this time now we have to check both against our restriction and check both against in a check. So for this one, our restriction looks a little bit different because if you look under the root sign, I get 5 minus n. That has to be positive, so greater than or equal to 0. So I would want my n to be positive, so I'm going to add it to both sides. You You could also subtract 5 and then divide by -1, but you'd have to remember that rule of when you divide by negative, you have to flip the inequality. So that's possible, it's just making sure you don't forget to do that. So at this point, I get something that looks like this. I have a hard time reading them backwards, so I'm going to flip it around. N is less than or equal to 5. So actually, both of these numbers are less than 5, so they would both pass that restriction test. And so now it's just a matter of checking them both. So we're going to check them one at a time. So first, let's check -11. So any place there's an N, I'm going to put a -11 in. So don't forget there was that N out in front. Then I had the subtract, and then I had the 5 minus N. So because N's a negative, notice how it makes a double negative in that bracket there. And then on the right side, I had a -7. So I don't have to clean up anything on the right side. I just have to do some cleaning up on the left side. So first I'll start with under the radical. So if I correct that double negative to be a positive, I'm getting 16 underneath the root. So I get -11 minus, and the square root of 16 is 4. So that's -15 is equal to -7. So that's definitely not true. So that would mean the N equals -11 is not a solution. So I would go and I would cross that one out, still being able to see it, but showing that it is rejected. So we're not putting no solution yet because we have another possibility as a solution that we can check, and that is the N equals -4. So we'll check that one next. So same thing with the substituting N. I have -4 minus the square root of 5 minus -4, and that's all supposed to be equal to -7. So correcting that double negative again, -4 minus square root of 9 equals -7. So here testing, the square root of 9 is 3. So continuing down the left-hand side, -4 minus 3 is -7. So I do get a match there. So my final answer would be the solution of N equals -4. So for an answer to be a true solution, it has to pass both the check and the restriction. So N equals -11 passed the restriction, but not the check. So it's rejected. Okay, last one. So here we're looking at doing some simplifying first. So if you have a look at this one and thinking about what would make sense for the simplifying, you kind of want to put yourself in the easiest possible situation. Because I've got this like +7 and +5, I would at minimum want to combine those together so I don't have to do FOIL twice. And then thinking about doing FOIL, I'd probably rather do FOIL on the left-hand side with the 3x instead of with the bigger 5x plus 4. So what that means is I would start this one by subtracting 5 on both sides. And so I'd end up with 2 plus the square root of 3x equals 5x plus 4 all under the square root. So I have 2 radicals for this one. One side's not so nice, I'm going to have to do some FOIL, but at least I'm not doing it with the bigger radical. So at this point, we're going to FOIL both sides, or we're going to square both sides, sorry. The only side we need to FOIL is the left-hand side because of the binomial. So I would say for this side, it's usually helpful if you actually write out both of the 2 plus 3 x's so you can kind of visualize the first outside, inside, last. On the right side, because everything's tucked in, I just go straight to my 5x plus 4. Okay, so on the left side, 2 times 2, our first terms together would be a 4. When I do inside, outside, I get the same thing since they match. And then here at the end, I have the square root of 3x times the square root of 3x. So since they both have square roots, it would be the square root of 3x squared. So I just get 3x. On the right side, I still have my 5x plus 4. So we'd want to collect any like terms and then isolate the radicals. So this is one that unfortunately we have to do twice because the roots are still there. So I'm going to move the 3x over to the other side. and I'm going to move the 8 as well over just to isolate, or not the 8, sorry, the 4, just to isolate that radical. So luckily the 4's go away, and I have on the left side 4 roots of 3x because I can combine them together since their radicands match. And on the left side, I'm left with a 2x. So this would be a good time to look, can that coefficient of 4 be simplified? Well, it could, but if I divide both sides by it, I actually end up, so I can simplify it in the stance that I can divide by 2 on both sides to make that smaller there, but I wouldn't want to divide by 4 because then I'd make a fraction on the other side there. So I've got 2 times the square root of 3x, and that is equal to x on the left side there. Okay, ready to square now? So I'm getting on the left side 4 times 3x, and on the right side x squared. So I get 12x equals x squared. Now some people might think, oh, I see a common factor of x on both sides and I want to divide by x. So we couldn't do this at this point because x could possibly be 0 as a solution. So that wouldn't be something we would be working on simplifying because of that fact that we don't want to have, we don't want to divide away a solution if that's a possibility. So here, what we'd be looking at is subtracting 12x on both sides. We'd be moving everything to the same side to try and solve for x. So this one ends up not being a trinomial where we factored like the last one, but this one, if you recognize that there are common factors with the x, so I could pull out an x and get x times x minus 12. So we practiced that in our solving section where we would factor out if we can't, do a full factor. We're just looking for a GCF. So now we can set each one equal to 0 and solve for x. This one, the solution is 0. This one, if I add 12 to both sides, I get a solution of 12. So I've got 2 possibilities. I didn't look at the restrictions yet, so I should do that next to see if they meet the restriction. So let's have a look here. So if we look at underneath the root sign, we had 2 options. We either had a 3x, so that's 3x has to be greater than or equal to 0, divide by 3. So x would have to be greater than or equal to 0. So both of those are good for that one. But this one has a second restriction, so that's 5x plus 4 also has to be greater than or equal to 0. So before we really start testing, we need to look at the overlap. So if I divide both sides by 5, I'm getting that x has to be greater than or equal to negative 5 over 4. So the best or the easiest way to figure it out is with the number line. So the negative 5 over 4 is over here. The 0 is here. Okay, if I map out something being greater than this one and greater than this one, the area where they overlap would be anything greater than or equal to 0. So both of those are greater than or equal to 0, so they pass that test, and now we're just going to do the checks. So probably the easier of the 2 checks is the 0, so I'm substituting in, so here's a check, does x equal 0? So it would be 7 plus the square root of 3 times 0 equals the square root of 5 times 0 plus 4, and that has a plus 5 at the end. So just make sure you copy it exactly like it was shown originally. So here I'm going to simplify the left-hand side first. So the square root of 3 times 0 is just 0. So I'm looking at a 7 on the left side. On the right side, 5 times 0 is 0. So I have the square root of 4 plus 5. So that's 2 plus 5, which is a match. So x equals 0 works. That's a solution. Let's now check the x equals 12 for our last one. So I got 7 plus the square root of 3 times 12. And that's going to be equal to the square root of 5 times 12 plus 4. and then that plus 5 is outside of the radical, so it'll be simplified after. Okay, so looking at the final stages here, so I've got 7 plus the square root of 36. The square root of 36 is 6, so I've got 7 plus 6, which is 13. So let's see if we get a match. On the right-hand side, so 5 times 12 is 60. 60 plus 4 is 64, plus that 5 at the end. Okay, remember this, like looking at this carefully, that's under the radical, the 5 is not, so it would be calculated separately. The square root of 64 is 8, so 8 plus 5 would be 13, so we get another match. So that means we have 2 solutions for this one, both x equals 0 and x equals negative 12, or positive 12, sorry. Okay, and that is it for solving equations. You can see there's a variety of types. There's all sorts of little situations that come up. The goal is to make the radical the easiest possible before you're ready to square it, and so that you don't end up with a kind of a big mess to simplify and figure out after. Okay, good luck with your practice. Have a good day.